Okay, so in this video we're going to be looking at absolute values, and in particular solving absolute value equations, excuse me. Okay, now if we recall the absolute value is part of our toolkit functions, right? So it looks something like this, all right? And can also be written, and again, absolute value, right? It does not care about the sign, right? It's essentially what that means, right? These absolute value lines here. It just says no matter what value you give the absolute value function, the result would be something that is essentially the distance from the origin. So we don't think of distance as negative, so it pays no mind to whatever the sign is. Right now, in terms of when we discuss piecewise functions, we said, all right, we can define the absolute value as a piecewise function. And the way we do that, right, it has two pieces. The first piece is simply we write it as x, right? And this is if x is greater than or equal to 0. And then negative x if x is strictly less than 0. Okay, so in terms of evaluating, let's say negative 3, right? This is very much less than 0, so it would be negative x. And there would be 3. Okay, so again, always the positive value, right? Now, in terms of using this fact, then how do I solve equations? Right, so what I mean is, how do we solve something like this, right? Let's do an easy one, right? The absolute value of x is equal to 3. Well, I already saw one solution here, right? X is equal to 3, negative 3, excuse me, but there's also the other solution, right? So if we think of this, right, what points in my number line are 3 units from the origin here being 0? Right, well, I found one already. That is 3 units, but that's not the only one, right? There is also positive 3, right? This is also 3 units from the origin here. Right, so as it turns out, similar to the piecewise, when I have an expression like this, in order to solve this, right, I get x equals to 3 or x equals to negative 3. Right, so we come across both of these solutions. Okay. All right. Now, how about something a little more involved, right? Approaching that. So here, let's say we have 4x minus 2 is equal to 11, right? And my goal here is to solve. All right, now when dealing with an absolute value equation, if you have it in this form where you have some quantity in absolute value or some expression equal to some number, right? Okay, so once we do this, I can drop the absolute value by doing one thing, setting up two different equations. We have 4x minus 2 equals to 11. So the first one is simply just rewrite it as is. Okay. The second one, similar to what we have here, would be to rewrite it. So it's going to be or, so it's going to be two solutions. 4x minus 2 equals to negative 11, right? So drop the absolute value, but in this case, make the value on the right of the equal sign here, make it a negative. And now we can go ahead and solve these, right? Now we have just two linear equations, right? Essentially what this comes down to, most of the time, is solving two linear equations. Okay, so here, let's add 2. We get 4x is equal to 12, divide by 4. And we get x is equal to 3. All right, so that's one solution. Right, the next solution here, we add 2. And we get 4x is equal to, what is that, -9. Oh, excuse me. Sorry, just working a little too fast here. Adding to is 13 over 4. Excuse me. Let me go over this one here. So we get 13 over 4. Okay. All right. My apologies there. Okay. And then here adding 2, we get -9 divided by 4. And we get x is equal to -9/4. All right, so that is our solution set, right? Our solution set is 13/4 and -9/4. Okay. And unless this value is 0, we're going to get two solutions. Now, if this value is negative, we'll actually have no solutions, right? Because remember, the result of an absolute value is always a 0 or a positive value. If the value in the right side of the equal sign is negative and we just have absolute value here, then there's no solution to that equation. Okay, so let's move on here. Okay, so let's do one more example here, a bit more of a application here. Let's say that we, in this example, I want to find the x and y intercepts of equal to 4 minus 1. Okay. All right. Now, if you recall x and y intercepts, right? So the x occurs when y is equal to 0. The y-intercept occurs when x is equal to 0. Let's start by solving the y-intercept first. The y-intercept, right? Again, what that means is x is equal to 0. Okay, so, and again, we use y and f of x interchangeably here, right? So y will be 4, x, I'll plug in 0. So we get y equals 4, absolute value of -3, right? These are multiplication, right? You can almost think of these as parentheses. Absolute value of -3 is +3. So we get y is equal to 12 minus 4. Y is equal to 8. So my y-intercept is 0, 8. Okay. All right. So that's the y-intercept. Now let's take a look at the x-intercept. Okay, and in this case, we'll let y is equal to 0. So we'll let this equal to 0. Okay. All right. And then we solve for x, right? So I can't drop the absolute value just yet, right? My goal is to have the absolute value expression to be on one side of the equation and every other number to be on the opposite side. So here I'm going to start by adding 4 to both sides. Divide by 4. Okay, so now I have like the problem that I started this section with. Yeah, some expression in the absolute value equal to some real number. So once we're here, now I can break it apart here without the absolute values. The first one being, just write it as is, don't change anything except dropping the absolute values. Or drop the absolute values and make the value, the number equal to or negative. In this case, -1. All right, and now I have two linear equations I can solve. Add 3 to both sides. X equals to 4. X equals to, add 3 to both sides, 2. Okay. All right. Okay. And that's how we would solve this equation here. And actually, let's write it in proper coordinate pair form. So those are my two coordinate pairs. All right. And I do have a rough sketch of what the graph possibly looks like here. Right, 1, 2, 3, 4, 5, 6, 7, 8. So crosses somewhere up here. 2, 3, 4. All right, so it looks something like that. Okay. Now, in the later portion of this section, we'll look into graphing these with a little more accuracy. Okay. All right. Thank you.